To do nightscape astrophotography, this is really about all you need. Just trying to do something. Okay, there's a picture of Andromeda that I took through my telescope. Well, we can try running it.
Can I take it tonight?
Yeah.
Is that up tonight? It is.
Okay, all right, no, I saw the date and the time at the bottom, and I thought it was,
Oh,
but it was just the computer. Never mind.
I took that picture about 4 years ago, but it hasn't changed much from our point of view. Yeah, I like that picture. That was taken with an 8-inch telescope and a DSLR camera. This camera here, and you can see the dust winding right down into the core of M31 there. So this is. Maybe I'll just let it alone for a little bit, because who knows, it might be working on it in the background. This is a 14 millimeter, fairly wide angle lens made by Rokinon, and it's one of the favorites of people that like to do wide field nighttime photography. If you're trying to do Milky Way or large constellations, things like that, this lens is very popular, and they make a model for Canon, Nikon, just about any Olympus DSLR that's out there. And what's really nice about it is it's not automatic. You have to focus it manually, so it's not, if you're used to pushing the button and letting it focus. In fact, for most nighttime photography, that's not going to work. You might as well just turn off the autofocus right off the start. But if you have the fortune to have the moon up, which is bright enough for autofocus to work on, you can use that to get started. Or if there's a yard light far enough away, you can sometimes get the autofocus to center on that and to get focus. But if you're able to do that, once you do that, don't forget, most of the lenses have, or your camera has, a place on the side that says manual focus or autofocus. You know, turn it off auto, because once you point it at stars and try to take a new picture, zoop, 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 it's just going to go nuts. It won't be able to focus on, get any contrast to work on the focus. So, but this camera has it's a 2.8, f2.8, 14 millimeter, so it's relatively fast. It is, it's relatively inexpensive. I think it was like, my wife's not here, she's the one that can remember numbers, not me, but it seems to me it was like less than $300 in that range. And for a quality lens, and this has, when you take pictures with your aperture wide open, I see many of you have cameras, so I think I'm talking to a pretty photo savvy group. If I go over your head or say something you don't understand, just wave your hand. I don't have a problem answering questions. But if you're operating your lens wide open, in other words, instead of f22, you're at f2.8 or f1.4 or one of those, so your diaphragm's wide open, letting all the light in, that's typically when you notice bad things happening in the corners of your pictures, because they don't focus on grinding the lenses perfectly out to the edges, just mostly the center, because most people are taking pictures of a face or something that's in the middle. And so they don't, when you're taking pictures of stars, you can see you can see a little bit of trailing in this one. I didn't guide it perfectly. But if it was a still shot and there are a lot of stars, they'll be kind of stretched out in the corners if the lens isn't a really good quality lens. That's why some lenses cost, $1,400 or $14,000, because they're perfect. They're all the way out to the corners. They're fast. And they're coated, they don't have a lot of ghosting or reflections. But for the money, this lens does a really good job, and it does a really good job right out into the corners. Sometimes ways to hide that, you can do a little bit of artificial vignetting, darken the corners a little bit to kind of focus the attention to the middle anyway, and then hide the defects in the lens on the corners, which isn't a bad way to do that, as long as you don't get carried away.
I have a question.
Yeah.
With such a wide-angle lens,
It seems like you need to have a, that was taken with the telescope though.
Right, yeah, an 8-inch Schmidt-Cassegrain.
So you use this to take
Are you-
pictures of the sky?
Yeah, the camera, when you take the lens off, of course, there's an adapter that has the same kind of flanges that the lens has on one end and is threaded on the other end. And so on my telescope, there's threads there that mate. So you screw that onto the telescope and then you can attach the camera to it. So the telescope becomes a lens,
So you're
basically.
not using this lens to take pictures like that?
No. Nope, more like a lens like that. Yeah. A lot of my pictures, I use a 4-inch telescope for wider field stuff. And I've got 2 8-inch scopes, different designs that are, it's like, I don't know what it's like. A lot of, if you're taking pictures of planets, you need a lot of magnification. And the more aperture you have, the better it resolves tiny details. So with planets, they're really tiny. You have to magnify them a lot. So the more aperture you have, the larger the diameter of the lens or the telescope, the finer the details you can resolve on Jupiter, say. If you want to take wider pieces of the sky, then a lens like this will do a better job. You can still see the object, it's there, but you won't see the fine detail in it.
I've got a question. When you're getting a telescope to attach to the camera, do you have to be cognizant of the size, or is the size pretty standard that it's going to attach?
They call it a T-adapter that you hook up to the camera, to the telescope. So on the one side, the threads are all the same through all telescopes, the T-threads. On the other side, the adapter that mates to the camera body is unique for each kind of camera. So if you've got a Pentax or an Olympus or a Canon or Nikon, then you'll have to have a T-adapter, and all of them they make the T-adapters for all these different makes. Then you can get the right one to attach to it. Most telescopes that you're going to do astrophotography with have what they call a 2-inch focuser. So the opening on the back of the scope is 2 inches in diameter. They also make 1.25 inches as the other most common size, but to prevent vignetting, you want to use the bigger diameter. So what they usually have is, instead of a camera lens here, they just have a tube that's 2 inches in diameter that slides into the focuser, and you clamp that down and then off you go. There's other ways too, but sure.
There's some that are orange and bigger. Are those closer?
The color comes from the temperature of the star.
What?
The temperature of the star. So hotter stars are blue. Cooler stars are like a red or an orange color. The larger, it just depends how much fuel there is in the star and how big it is. If it's really, really, really massive, the pressure is it burns a lot of fuel really fast and it's really hot. If it's near the end of its life, it's burned up most of its fuel, and it kind of pushes its atmosphere away from itself. And then when it does that, it expands and it cools and it becomes like a red giant. So if you look at Orion's a really good example, the constellation Orion. Up in the top left of Orion, there's a bright orange, pumpkin orange colored star called, I had it in my head a second ago, Betelgeuse, yeah, Betelgeuse, however you say it, Betelgeuse. Up on the left and the bottom right is Rigel, and they're opposite. So this one down, Rigel, is a hot blue supergiant. They're both big stars, but the supergiant star, but it's early in its life cycle, and it's really hot and it's blue. Just like if you hold a piece of iron in a fire, it'll start to glow orange-red first, and then as it gets hotter and hotter, it'll go to white or blue. And so same thing with stars. So you can tell a lot about the star just by looking at the color of it, the temperature, and then of course if you use a spectrum, you can find out what chemicals, iron or carbon or whatever is inside the star as well. Well, why don't I just go through the talk and I'll just show you stuff on the camera even though it's far away. Well, so first of all, before I do that, I guess, So these are the basic things you need. A good tripod that's sturdy, and I've got the legs all the way extended on this, but when I do the photography, usually if there's any wind at all or any reason to think that it might vibrate, I'll always drop the tripod closer to the ground, not have the legs extended all the way. That makes it more stable. Some people even will take sandbags or water bottles filled, they fill them up and then empty them when they leave. But water bottles chained to this to give it some weight to take out any chance of vibration, because any vibration that you have, even a little bit, is going to show up in the stars. They'll be egg-shaped or blurry. So you want as stable a platform as you can possibly have with your camera. This thing, this is called an intervalometer, and you can program this. You can put the camera on manual and then turn your shutter speed to bulb, to the B setting. And then you can tell this, I want to take 25 pictures, 30 seconds long each, with a 1 second pause in between to let the image download to the card or whatever, however much time you need. And then you can turn it on and then just sit back and watch for meteors or whatever, and it'll just go. And that's really handy. So these things cost like $14 or $15 on the internet. This one's made by Niwer. It's just a Chinese company, and they kick them out. There's lots of different names, but they look exactly the same. So Niwer, N-E-E-W-E-R, and it's called an intervalometer, I-N-T-E-R-V-A-L-O meter, intervalometer. You can, of course, use, if your camera, the point is you really don't want to use the shutter to take the picture, because when you press on this and let go, you're likely to introduce some kind of shake to the camera. You can also use, if your camera has a remote, it came with a remote, you can click it to take the picture there, get everything set up, and whatever the length of the exposure is going to be, the duration of the exposure. You can use that to click them off. You can also just use a regular cable release, anything to try to get your hands off. If you don't have any of those, most digital cameras these days come with a self-timer so that you can run around and get into the picture, either 6 or 10 seconds, something like that. So you can set that up to do that. So you can click on it, and then it'll count down, and that'll give it time for any vibration to settle, and then it'll take the picture for you. So anything to get rid of any vibrations, because you don't want that in your image. That's going to make a mess. Let's see. If you can do some pretty nice work even with a cell phone. If you have a cell phone, bright things will show up. Most of the time you need at least 15 seconds. So if your cell phone camera has some manual settings to it, kick up the ISO, set your shutter speed to long time, put it on some kind of a tripod mount or a holder like a selfie stick that you can clamp to something, and then you can take some pretty nice pictures with even just a cell phone camera. Maybe that's my problem. I'm using an old version. Hey, look, it showed up. Yay. Oh, good, pretty pictures. All right. So, and of course, I'm Jim. I've been doing astrophotography with my telescope for about 12 or 15 years. And I've done a little bit of this night sky type stuff. This picture's made by my wife, Deb. And she ran home. I brought something called a sky tracker, or we were supposed to bring something called a sky tracker to show you what they look like. And it got left behind. And since it's hers, and it was her responsibility, she went home to get it. So, but that's kind of late in the presentation anyway, so she should be back by the time we're ready to look at it. This was taken over by Three Bridges Park over by Quarry, and so we went up the hill in the back there, and she got that picture, and that came out pretty nice. I thought I'd show you some of the deep sky stuff that I've done. This is a picture of Andromeda. This is the whole galaxy. The picture we were looking at before was just, the core part of it. But this shows you the whole galaxy. And actually, this is one of Deb's pictures. And this galaxy, and this galaxy orbit the big one.
Sounds like I walked in just in time.
Yeah, you got it back just in time. We had trouble getting the PowerPoint to start.
Oh,
Maybe it'll give time for the clouds to roll away that were out there. This is M42, the Orion Nebula. And what I was hoping to take pictures of tonight was Orion. So this will show up, not this big, it'll be tiny as part of the picture, but you can see the pink and some of the blue stuff in just a nice picture of the Orion constellation. This is the Pleiades, which is also up tonight. It precedes Orion through the sky. You don't generally see all the blue except in long time exposure pictures. And this is my most recent picture. This is also up in the wintertime. It's in the constellation Gemini. And this is actually a combination of two sets of data. One I took about 1 hour and 5 minutes with my DSLR in my 4-inch telescope. And then I rented some time. There's telescopes that you can buy time on over the internet. And there's some in California and some in New Mexico and different places around the country. So I bought 45 minutes of time on a telescope that's similar in size to my own and got what they call HA or hydrogen alpha data, which is a special emission line. And I blended that data, 45 minutes, with my picture, and it made a really nice shot, I think. You can zoom way in and see lots of detail in those dust clouds and things. The kind of photography, and then this was the one that my wife had bugged me for years to finally take the horse head. That was, she finally got her wish. So that's also in Orion. This bright star here is the 3 stars in the belt of Orion. Most people are familiar with that part of the constellation. That's the leftmost star. So that's it there, and then these things come off of that. My first attempt at this, I was using film cameras and my C8, and I was having problems. And I got a real nice picture of the Flame Nebula, but not the, because moving it around, getting guide stars, and it was a big hassle. But anyway, this was taken actually with a camera lens, with the camera attached to the back of a telescope, so it was tracking the sky. This is called the California Nebula, and you can see lots and lots of red stars in here and some blue ones. The red stars, there's actually a cloud of gas and dust between us and the stars. And the gas and dust filters out the blue light and only lets the red through, kind of like sunset. The sun looks redder at sun because it's coming through a lot more atmosphere. And so there's a lot of dust and gas in this region. This part glows because there's some real hot stars pumping ultraviolet radiation into the gas and making it glow, just like these lights here. The electricity goes through and excites the the gas that's in those tubes and makes it light up. Same thing here. But this was taken with a kit lens, a 55 to 250 millimeter zoom, f4.5, not very fast, not real good quality lens. It was zoomed to about 200, and with an APS-C, the smaller size sensor, not a full frame sensor, that makes it probably in the neighborhood of 275 or maybe in that area, millimeter lens equivalent. But this thing's really big, so I tried to take it with a telescope, and all I was getting was like this part. So the camera lens worked really good for that one. And there's a lot of really big things out there that we can get with just our cameras and lenses. This is the sun setting about 4 years ago, and the moon, it was just starting an eclipse of the sun as the sun was setting. So we didn't get to see totality like we did last summer, but that still came out to be a nice picture.
Do you recall what the settings were on your camera for that?
It was pretty fast. It was something, I had the ISO down around 100, and I had the shutter speed was about fast as I could make it go, 2,000 or better, 2,000th of a second. And this was also, let's see, this was my 30D, and I was using that zoom lens, that same 210 zoom. It was zoomed far in as I could make it go. So it was cutting down the light. And as you can see, it's very red. There's some clouds in here, which is dimming it down some. So that helped. This thing doesn't, the shutter speed's not as fast as well, maybe that was, the 30D, it goes a little faster, so I can't tell you exactly for sure, but it was about as fast as I could make the shutter go and low as the ISO as I could do. But it came out pretty nice. You can just, the nice thing about the DSLRs is, you know, you got preview. You take a picture, oh, too bright, too dim. You can adjust things until you get it so that it comes out right. Took this picture. This is the one that won the last year's photo contest. The lights from inside here are just the exit lighting. All the other lights were off in the building. So the exit lighting made a nice red and pink. Interior lighting. This, of course, is the parking lot lights lighting up the trees here and the grass. And then, of course, we have the Milky Way there. And you can see a couple constellations. This is Aquila and the little constellation Delphinus. And so up here would be Cygnus. And then down below here, this, my wife says I can never see it, but this is the handle, this is the teapot lid, and this is the spout, and steam's coming out of the teapot. So that's Sagittarius. So I know it's easier if you see the lines drawn on it, but you can imagine the old Maxwell House coffee. Those of you who are old enough to remember that pot that you set on the campfire, you know, it has a nice triangular, you know, lid. Anyway, besides taking pictures of stars that stand still, we can actually let them move and make star trail pictures. So this was, Deb took this picture at the Creation Museum in Kentucky, and there's Polaris here, and then all these stars, we let this go for about 35 or 40 minutes. And this particular, you can either do it two ways. You can have your camera lens just open for that amount of time if you're in a dark enough site. And as the Earth rotates and makes the stars appear to circle around Polaris, it will create those streaks and give you the feeling, a sense of motion. Or you can set your camera up like with the intervalometer, which is what we did for this picture, and take a series of 45 minutes worth of 30-second exposures at fairly high ISO. We were struggling with this picture. Of course, we had all these lights here and inside the museum. And then there was also an almost full moon. And then in addition to that, all these clouds are moving. So every frame, the clouds are moving through, you know, like one of these stop action movies. So to get the picture, it took a lot of work. We had to do some fancy Photoshop stuff to get rid of the stars, tone down the museum, and then put the stars back in. And another program that's called StarStax, which is free, it takes all the individual pictures that you did and just kind of stacks them up and makes the lines appear. Maybe that was the wrong button. I guess I'm missing one. Yeah, it's missing part of the picture too. This is the courthouse, Marshall County Courthouse. Deb and I took this picture together. We were up on the overpass on 6th Street where it goes over the railroad tracks. So we were sitting on the grass on the north side of the bridge there and looking out over. So we got the picture of the courthouse, and that StarStax program has an option that can make them narrow and then fatter as it stacks them. So it gives that kind of a comet effect. I thought that was kind of...
What's the band of color at the bottom?
For some reason it didn't download the picture all the way. Some defect. On my original slideshow it looks fine, but Microsoft didn't. It said it was done saving, and I trusted it when I got done with the PowerPoint, but obviously it didn't do it right. This is a star trail picture of I pastor Stavanger Friends Church and work part-time at Mitchell Funeral Home. So some of you may recognize me from Marty's, but this is my church, and this is about a 40-minute exposure, and where the skies are really dark and you're not dealing with clouds and stuff like that, a lot more stars. And that's a fun thing to do. It's really easy. You set up your camera to take a series of pictures, and then you feed it to that program, and it just makes it for you. Or if it's dark enough, you just turn it on and let the shutter go for 30 minutes, and then you get it in a single shot. The advantage to doing it with individual shots, you can kind of expose for the foreground, so you get it about the way you want it. And then when you take all your pictures, you're fine. If you have it shutter open for a long time, of course you're going to blow out anything that's got any kind of lights on it. Like these little lights here, these are some of those things you stick in the ground and they've got a photocell on them to light up at night, you know. They're really dim, but they look really bright in that because there's so many of them, so many exposures.
Do you use Photoshop on that or PhotoStack?
It's called Star Stacks, STARSTAX.de. It's somebody in Germany that wrote it. It's free, it doesn't cost anything. And looks like some of my pictures are going to show and some are not. So, okay. Basic equipment. So like I said before, we have a camera capable of taking, the picture that's missing is looking the other way from the church at the south, which is a similar picture to this, but without the trees to show the Milky Way. Basically, you need a camera that's able to take 15 to 45 second exposures. Any more than about 40 or 45 seconds, and you're going to start trailing in your images no matter what you do. So unless you have a camera tracker or something like that, but if you're just on a tripod, the maximum you're going to be able to do is probably in the neighborhood of about 35 or 40 seconds. And so your camera only has to be able to stay open that long. A lot of little point and shoot cameras have that capability, 15 to 30 seconds or a minute. So even a small camera will work. The bigger the lens, the more light you get in, the brighter the stars, the brighter the Milky Way is going to be. So these are preferable, but if all you have is a little point and shoot Nikon or Canon or one of these little small cameras, they can do nightscape photography. I've done some really beautiful northern light pictures using a small, it was a Nikon 5400. So it was, it didn't have interchangeable lenses. Or did it? I don't think so, nope. It had a, you turn it on and the lens telescoped out. And it did a great job because it could do that 30-second exposure. You want a wide-angle lens. The faster the focal ratio, the better. So like you want f1.4, f2, something, small number where you see that little f number if you're not real familiar with camera lenses. That just means that it lets a lot of light into the camera so you can have shorter exposures and still get it well exposed. A sturdy tripod, we talked about, we don't want the wind shaking our camera, or if you're walking, even just walking around can put vibration into the tripod and into the camera. So that's why people put weights on the center to anchor that thing down. If you put it on sand, if you're at the beach and taking pictures, make sure you let it settle for a while because the sand will slowly shift and you want your tripod to be settled before you start taking any pictures. You need some kind of a shutter release like we talked about earlier, either the remote control, a shutter release cable or an intervalometer, or you can use the camera self-timer if that's all you have. But any one of those things to, again, reduce vibration. You don't want any vibration in the camera. Some things people don't think about, it gets cool at night. We experience a lot of times people come out to Greencastle where we have the observatory, and it's a hot day, it's in the 70s, 80s, and then at night it cools down to 60 or 65 or 50, 50. And they get cold, and we're there with our coats on, and they're shivering because they're so cold. So, you're gonna be just sitting probably, and it's the cool air and the dampness, you wanna have a good jacket or sweater, and don't forget the insect repellent. Keep away the mosquitoes so you're not swatting at them, because the more you move around, the more likely you are to kick the tripod, which always ruins pictures. And or just it's not comfortable, it's not fun, you won't want to do it the next time. It's a good idea to have a red flashlight to be able to, if you don't have all the controls memorized on your camera, it's hard to figure out sometimes what you're doing in the dark. So a red light will help you be able to maintain your night vision, so to be able to see stuff without stumbling on it in the dark. So a red light's a good idea for that. On the other hand, a white light with a diffuser on it can be handy for, in this picture, the trees are all more or less just a silhouette. There's no color in them. But if you have a weak light, a white light source with a diffuser so it's kind of soft, you can kind of wave it around and kind of paint light onto those trees. And in the dark, with the camera open like that, you get some nice green and color in your picture because you can do some light painting. In fact, a lot of people go out west and they take Milky Way shots around the Sedona and stuff with the beautiful rock formations and the Garden of the Gods and stuff. And from a half a mile, quarter mile away, they can use a small LED diffuser and they can light up those mountains enough that the camera can pick it up, and you have you can see what the rocks, the layers and the colors, and get a nice picture. Even it's amazing what these cameras can do, given just a little bit. And then it's always nice to have a folding chair to sit on while you're watching for meteors, waiting for your exposures to get done. So don't forget any of that stuff. Oh yeah, and then maybe something to drink, and no alcohol, water, hot chocolate, something like that, but alcohol messes with your ability to see in the dark, and you want to be able to get back safely to your car or whatever. No stumbling, no dropping expensive equipment, no alcohol. So just some advice. I'm a preacher, why can I help it? So the settings that you want to look at, how long can I take an exposure before the stars start to move and trail? There's something called the 500 rule, and you've probably heard 600 rules, 400 rule, 500. There's different rules for different stuff. For astrophotography, generally, the 500 rule will give you a starting point. You have to really experiment with your own individual equipment to see what works best for you. But if you take 500 and divide it by the focal length of the lens, that'll give you the maximum exposure length in seconds. So, for example, a 50 millimeter lens divided into 500 would give you a 10-second exposure before the stars will start to trail. And one thing you have to keep in mind is, what do I intend to do with this picture when I'm done with it? If I'm going to be showing it to people on my cell phone, a really tiny screen, you can have pretty badly trailed stars and they won't notice unless you pinch zoom in and, and show them. But if you leave it the right size, they'll never notice. If you make it 5x7, you might need to have a little bit more accurate, but still a little trailing probably won't show up on a small. You make it a 17 by 11, then you better have pretty good, keep your trailing down by keeping the exposure shorter. Another example, this camera lens here, the 14 millimeter, divide that into 500 and you get 35 seconds. So you can see why astrophotographers who do this a lot like the 14 millimeter size lens. I took a picture similar to Deb's when she was taking that picture of the Creation Museum. I took one too, and I used my 18 to, I forget, 55 I think, zoom, down to 18, and it did a pretty good job, but you could tell the field of view was definitely not as wide as hers, and but as far as the exposure and everything else, that was fine, just didn't have as big a view of the sky. This is kind of what I'm talking about. That 14 millimeter lens, a 90-second exposure, you can see all the stars are little streaks, just like the time exposures I saw, this small segment. The 30-second exposure, though, the stars are nice little dots. If you look really close, you can see there's a little bit of an egg shape to them if you zoom way in. But for all intents and purposes, for most display, I mean, look how big that screen, it's enlarged quite a bit, and those stars look pretty good. So it's important to look at that when you're taking your pictures. And no matter what the 500 rule is, in the end, you have to look at your pictures and see what it's doing. So it's nice to have a camera that has the review function and the ability to zoom in at least 10 times or to 100% size if you can, to see exactly what those stars look like. The aperture setting that you want to use is, well, the lower the better. So if you can set it to not f/22, that's when the aperture is really tiny, everything in the world is in focus. When you're taking pictures, you can be real forgiving with focus. But for stars and for getting as much light into the sensor as you can, you want to set it the other end instead of f/22. You want it down f/1.2 or f2.0 or whatever the lowest number is on that ring. And on this camera, take this off. So, you know, it's the ring that's closest to the body. The 22 is there, and then this one, the 2.8, in this case, is there. So you would turn that ring to have the smallest number at the indicator, if you have your camera with you. And then, you know, also it says on here, infinity, and you'd think, well, if I just set it at infinity, it should be good, right? Well, no, not usually, unless you got a really good lens. You're going to have to, we'll talk about focus in a minute, but okay. So aperture, the lower the better, but there are some problems too with real low aperture pictures. We talked a little bit about that earlier. Focus becomes much more critical than usual because as you lower the f-stop, you decrease the depth of field. So if you're focusing on something and the f-stop is real small, you know, the front might be in focus, but the back of this thing might not. That's critical when you get down in the real low f numbers. So you have to be very careful that you take time to get good focus. And don't skimp on that because you'll be out there in the dark battling the mosquitoes and listening to coyotes in the distance and what are those beady eyes looking at me? Is that an owl or is that something else that I don't really like? You risk your life to get this picture. You want to make sure it's in focus when you get it home. So with low aperture, you have to make sure that you pay real close attention to your focus. Vignetting and darkening in the corners will occur more often as you lower that f-stop too. So that may or may not be a problem. That actually helps draw the eye to the middle of the picture. So that kind of helps. A lot of people add vignetting in post-processing, but you want to just be aware of that as you're taking your pictures. And some of that can be taken out. You know, in Photoshop, it can brighten up the corners and take that out. So that's not a big deal, but something to be aware of. And then, of course, as we said before too, the cheaper or less quality lenses will show more aberrations in the corners. See, Debs are nice round dots in the corners, so this is a good lens. It does a good job. I think this is cropped a little bit, but it's not bad. Your ISO setting. So the things you can control with the camera is your aperture, your shutter speed, and your ISO, which is really kind of the word for sensitivity of the sensor. The higher the ISO number, the more sensitive to light the camera is. And so the higher the better, because as you only have a certain little bit amount of time, somewhere around 25, 30 seconds. So the more light, the more sensitive you can make the sensor, the more stars you're going to record in the short time that you have before they start to trail. But then, of course, there's always trade-offs. So the higher the better, but also the higher you go, it may introduce more noise into the background. So you have a kind of a grainy texture, and the stars will look kind of rugged and coarse and maybe not quite as soft and pretty as your eyes see them. So you have to kind of play with your ISO to get the highest setting you can with the least amount of noise in your images for the time that you have to expose with. So let's talk a little bit about focusing. The first thing I think of, stars drive autofocusers crazy because they basically work on contrast and there's just basically none when you're pointed at the sky. If you have the moon is partially up somewhere, you can use the moon, and the moon is not always your enemy because the moon will help light up the landscape for you. So I've got some nice pictures out of Greencastle Park. The water's reflecting the trees and it looks just beautiful out there, and then the Milky Way's coming up in the back. So the moon's not always your enemy unless it's really bright. You can use the moon to focus on. You can look at if there's a yard light in the distance. Those are sometimes bright enough for the autofocuser to glom onto. Otherwise, though, once you get it focused, remember, turn off autofocus if you're using that. And while you're at it, make sure that the flash isn't going to go off either. It's not going to help, and it will definitely mess up your eyes. A tool that I like to use is called a Batinov mask. The inventor's name was Batinov over in Czechoslovakia or something. This is what they look like. It's just kind of a circle, and it has these slots in it, which cuts down on the light a lot. So you have to, especially with a small lens like a camera, I use these for my telescope, but you can use them for your camera too. You have to take a 5 or 10 second exposure to get enough light to make it work. But these are made, these little tabs are, you can get them, they're about $15, they're not expensive. They're made out of a stiff plastic, and you can push them into like a clear aperture, like a sky or an ultraviolet UV filter, and then they'll just kind of sit inside there and just not do anything. So kind of dedicate that for this purpose. What happens is when you take a picture of a bright star, you get an image like this. Those slots make diffraction spikes in the star. And if you look closely at this image, the center spike here is kind of shifted to the left side of this blob, right? So it's too far out of focus. So you change the focus a little bit. Now it's better, but it's on the right side of center. And then this one, they're exactly center. When you get that pattern where they're exactly centered, then you're in perfect focus, and then you don't forget to take the thing off. Or all your stars are going to look like that. So you don't want that. But you want, this is really nice because if it's already like this when you put it in and you turn it the wrong way, it's going to be even more over here. It'll keep moving this way. So you know, oh, that's the wrong way. I want to go back the other way. And then it'll work its way back. And if you go too far, you'll know. It's a really quick and easy and way to do focusing at night. Just point it at whatever the brightest star in the sky is at the beginning of your session. Set the focus there, make sure the lens is on manual so that you don't mess with it. And sometimes people aren't sure. This is actually, a manual lens, so the focus is by this. Even the autofocus lenses, the ring on the end is usually, if manual focus is on, you can manually change that. And you just have to figure out for your camera how you do that. So other ways of dealing with star trailing: use a single shot, short exposure, high ISO. You can take multiple short exposures and stack them together, either manually in a program like Photoshop, or there are programs out there like Deep Sky Stacker that you can feed it a bunch of images, and then it'll automatically find all the stars, and then I'll match them all up in each image and then stack them together. And the way they do that is they add all the values of the pixels together and then divide by 2, and then they add all the pictures. The third one, they match them all up, and then they divide by 3, and then it's a weird process, but it makes a really nice picture. It eliminates the noise. The noise that's in each image is random. So each image has stars here and Milky Way stuff here and trees and things. And from image to image, those don't change because our camera's just sitting, not moving. But the noise that's generated by the sensor from heat or from just stray gamma rays or something that are coming in and make lines and things on those keep moving around because it's just random, usually from heat. And so as you stack up images, all the stuff that's steady, all the stars, all the Milky Way stuff, it stays there. But all the noise stuff starts to just kind of smear and blend together and becomes a nice neutral gray background. And so then you have all your signal and no noise. So the more images you can stack together, you can eliminate a lot of the noise in the pictures. And you can see this is a little bit grainy, and we've done some work on it to smooth it out a little bit. But an individual image, you can still get pretty good results without doing hardly anything to it. But you can, if you learn your way around a little bit, you can make the images really, really come alive. And the third way to do, so you can do the multiple short exposures and stack them, or you can use a star tracker to simply follow the stars as they move across the sky. Both of these methods, the main problem is, notice that the trees are a little bit blurry. They're not real clear. That's not because she didn't have focus set right. It's because she had her camera on that tracker thing there. She's going to show you in a minute. And so the sky was moving, but the trees were not. So the stars are nice and sharp, but the trees are nice and blurry. So you can get around that by taking one of the individual exposures of the trees and stuff in Photoshop, and once you've got your background sky the way you want it, then you just cut out the trees and plop them on top, right over top of the blurry trees, and then you got nice sharp trees and nice sharp stars. So it's kind of cheating, but it's real. It's not like you drew the trees or something. They were there. You just got rid of the blurriness. Some people like to have the trees blurry. That's okay too. It kind of gives you a sense that there's motion, there's movement there. So I'm going to let Deb. This is what. I'll just show you real quick. There's a lot of different star trackers out there. This is one. This is what they kind of look like. This one has a counterweight. If you have a really heavy setup, then you might need a counterweight for it. Some of them, like this one, they have a little telescope here that points at Polaris so that you can get a polar line. It's important to be pointed at the North Celestial Pole so that your camera is describing the same circle across the sky as the stars are. If you're not pointed at Polaris, the stars may be going like this, but you might be centered somewhere else, so you're going like this. So the two motions kind of overlap, and then you don't get, you still get star trailing no matter how hard you try. But it's on a ball head mount here on your tripod, and there's a little motor in here that drives this thing, so it follows the sky once this is lined up with Polaris. And he's got it pointed north, and I don't know why you do that. Most of the time you point it south. This thing's pointed north, but you want your camera pointed south at the Milky Way, unless you want to take pictures of Polaris, but that's not very interesting. You can see most of them are in the range of around $300 to lots. These guys here, they're talking about the price of this part of the unit. Not talking about the equatorial head or the counterweights or the ball head or anything else. Those are all added accessories, so they cost mounts up. But if you get the basic unit, that's good enough for what we're talking about. This one only weighs about 1.5 pounds. It's about the size of a small, like a paperback book. So it's easy to take with you on vacation. You can throw it in, and when you're in Hawaii and you want to get some pictures of beautiful stars over the volcanoes or over the ocean, that's easy to put in your suitcase. Doesn't take up a lot of space, doesn't alarm the security people. So.
Okay, so when we decided to get one of those, I went out to the internet, and of course I wanted a pink one. I got red. That was the closest I could get. So this is it's got either 1/4 or 3/8 connection, and it also has a polar finder viewer that goes into it, and I have software on my cell phone, which you wouldn't be able to see, but you can come up and see it later, that shows me where the North Star is, and then I can look through the polar finder and move my rig around so that it lines up, so I know that it's pointed north and it's going to track the stars. This part just slides on. Then I won't get it right. If I can get it on straight. And it's got a little level on here, so you can adjust your tripod so you know that you're level. And so I just slide that in and tighten down my screws so that it'll stay. Why do I have to tighten it so tight? When you put this in, am I doing it backwards? Which? Oh, that's right.
It's out, don't take it out anymore.
And then, let's see, I need a ball head on top, right? Jim?
Put the ball head on first. Deb doesn't usually do any of the talking. I wanted her to talk a little bit. A little nervous. The ball head goes on this part. This is what rotates with the sky.
And then there's a plate on the bottom of my camera that fits in here. There's a switch there that you turn on, and then there's a half sidereal and sidereal rate that you can set. And I'll let you explain what those are for, because I don't.
So once you've got this attached on here and it's turned on and tracking, then get that done. You can point this any direction you want in the sky, and it will follow the stars very well. So you can, if you want to aim it in the west, if this is pointed north, the straight south would be like this, and then the east or west. So it's a very nice, small, compact unit. It has built-in batteries. It charges with a USB. Plug it into any cell phone charger or laptop, and it'll charge the batteries. And it has a latitude adjustment here. You can get it roughly in, 42 degrees north latitude. You can get that adjusted. And it does a really nice job, as you can see in that picture there. It tracked very well. That's actually a stack of, about 5 pictures, and we tracked for, I think, 90 seconds each or something like that.
45 seconds.
45 seconds. So way beyond the limit of what 38 would be maximum. We went 45 seconds, and 38 probably would have had some egg-shaped stars. But with this thing, it did a real nice job of tracking with the sky. So then I just put a little bit in here about post-processing, and then we're done. There's not enough time to go over that. So what I said was, some post-processing will definitely help your images. No matter how nice they are, they can probably be cleaned up. Light pollution near the horizon can be cleaned up a little bit. Some of the noise in the image can be taken out with some smoothing filters, things like that. But there's lots and lots of really good tutorials on YouTube. If you just get on YouTube and search for astrophoto or Milky Way processing tutorials, tons of them. And I've watched many of them, and there are lots and lots of really good ones. So there's nothing like watching somebody show you how to do things to learn what to do. And so I would just recommend, rather than me taking all the time to explain how to do image processing here, just go to YouTube and check that out. This one website that I would recommend is called lonelyspec.com, astrophotography-101. And he has a lot of written tutorials, a lot of written information for the beginner and for the advanced astrophotographer. And so I would definitely recommend that you visit that website and check it out. He has a lot of good stuff there. And the same thing, YouTube for image processing, Photoshop, starstacks.de, or the Deep Sky Stacker, which will stack your images. Those are free programs. They don't cost anything unless you want to send them a donation, but they're free. And so that's it.